In this video, we're going to do examples of drawing a triglyceride and a phospholipid. These are both esters of glycerol. You will not be told how to draw glycerol. You must know that glycerol is 1,2,3-propane triol. Let's draw that first. We've got OHs on carbons 1 and 3. One, two, three, propane triol. I'm going to make it nice and big so we have a lot of room to draw our fatty acids. Similarly down here, phospholipids have the same glycerol backbone. We're going to convert every OH into an ester. 5 of those esters are going to be carboxylic, and one of them is going to be a phosphoric ester. Let me start with that one. Phosphoric esters, double bond. Oops, that's going to be a P there beside the O. And oxygen surrounding all the way around. There's a phosphate ester. In truth, when we're done, it will be a phosphodiester. Every other O will be an ester with a carbonyl. So I'll take a second and make that happen on every other O. In the top one, I'm not concerned about what order you put these on, as long as I see an ester of each. I'm going to start with Myristic Acid. Another name for Myristic Acid would be tetradecanoic acid. It has 14 in a row. So I need 13 new carbons off of that top carbon. And looks like that's 13 more. Never trust yourself drawing stick figures. Always verify. We need 14 in a row starting with the carbonyl. 1, 3, 5, 7, 9, 11, 13, 14. Good. Moving on to linolenic. Linolenic, please make sure you start from the right side. That's where the carbonyl is. There are 7 extra carbons off of the carbonyl right here. Let's get those on the page first. 1, 3, 5, 7. That's our 7th. Our 8th one in is part of a double bond. We see right here. The 8th one, double bond to another C, and then a CH2. So let's draw the 8th one with a double bond. And read very carefully. This red comment won't be up here on your test. You need to know that cis double bonds are natural and trans are not natural. In fact, they're unhealthful. So there's our cis. So we've done our first parenthesis. Here are the 3 carbons in the parenthesis. C double C, then CH2. We have to do that 2 more times apparently for linolenic. Watch your spelling. Linoleic and linolenic are very different. So we have to do C double C, CH2. 1 more time, and there's the CH2, and then C double C. Better go this way. Ooh, that's trans. And I lost a carbon. There's the CH2, there's the C double C, and here's the end of the 3rd parenthesis. Make sure it's cis. Good. We finished with the parentheses on linolenic, and it looks like we only have to add 1 more carbon. Linolenic is a very healthful fatty acid because the end of a chain of fatty acids is called the omega carbon, omega 1. And omega 2 is the next one. Then omega 3 is this one. This carbon is an omega 3, very helpful. 4, 5, 6, omega 6, also helpful, not quite as helpful, but very helpful. And omega 9. Good numbers for omegas. Moving on to oleic. Oleic, we need to draw 7 in a row off the carbonyl once again. Here comes 7 in a row. I did 6. 2, 1, 3, 5, 6. Need 1 more. Going into the parenthesis, you got a C double C that has to be cis. And we've already exited the parentheses. Where are you, Oleic? You're here. We've put the first CH2. We need 6 more, and then a 7th one for CH3. Yeah, there we go. I'm going to make sure we have the right number. 1, 2, 3, 4, 5, 6. I need the 7th and then the CH3. Trying to make it look halfway nice. Doesn't have to be halfway nice. That will get full credit on your test. This molecule, if you were asked the question, oh, this won't get full credit. I talked the talk and I didn't walk the walk. Look at this. There's supposed to be a CH2 between these. Somebody probably spotted it a long time ago. It's okay to make mistakes. Fixing them is what makes life worth it. There you go. And this brings us to the end of that third parenthesis. And I'm going to verify everything from this. We had one more carbon. The omega-3 discussion is still valid here. CH3, CH2 in the parentheses, C double C, CH2 in the parentheses, C double C, CH2, the third parenthesis. We should have 7 here. 1, 3, 5, 7. Verifying all the fatty acids have even numbers of carbons, and glycerol has an odd number. I'll just view my analysis window real quick. You don't have that option on a test. Good, we have an odd number. The fatty acids all even, glycerol odd. 3 evens and an odd gives an odd. And moving on. A phosphatidyl inositol has a phosphodiester. We've already got the first ester to glycerol. Second is to inositol. We're told inositol is cyclohexane with OHs on every carbon. That's what the name says right there. You didn't have to learn this. It's right there in the question. Sorry about the stray bond there. OHs all the way around. Here's your generic inositol down here. I have to apologize. I believe I said our omega-3 discussion as before. I didn't mention why this is an oil molecule instead of a fat. If I did, I'm going to repeat myself. Please forgive me. This is an oil molecule because in this area here, or in the molecule itself, there are 4 alkenes. Each alkene cis geometry gives a kinkiness to the shape, which means these molecules can't pack very well on each other, and they are liquids. If they were saturated, they stick on each other, and they'd be fats, which are solids. The guideline is if you have more than 3 alkenes, you're thinking oil. If you have less than 3 alkenes, you are thinking fat. Exactly 3 or on the borderline. You're going to be waxy, oily mix. On to chairs 101. The reason we learned chairs in Chapter 2 was so we could apply them right now. Drawing a chair, I'll just do it on the middle and move it over to my molecule when I need it. We need a parallel line here and here on a slight angle. That's good. And we need to draw from the inside corner of that one more than halfway to there. And same length as that one I just drew here. Finishing the connection, and we have what looks like a pretty good chair. All the parallel line things hold. The axials, I'll put all the axials on. And they're easy to predict, the axials. This angle here points upwards, axial is going to be straight up. Angle here downwards, axial straight down, and they keep alternating as we go. Axial up, axial down, axial up, axial down. I'm going to erase the axials I don't really need after the fact. And in this over here, it says this mucoinositol has 3 axial hydroxyls in a row. I'll do those here on the right side. Axial OH right here, and here, and here. And make the molecule a little bigger and the writing a little smaller. And there we have it. And We have to do the 3 consecutive equatorial hydroxyls in a row. 3 equatorial hydroxyls in a row. If the axial is straight down, the equatorial is slightly up and parallel to this bond and this bond. Parallel not to the adjacent bond, but the adjacent to the adjacent. I hope some of you remember that. Next equatorial is here. Parallel not to this bond, but to this bond and this bond. Pretty good. I could lower it a little bit and it'd be even better. Too much. There we go. And there we go. And that's 2 in a row. Third one is over here, and it doesn't go that way. That's not parallel. That way. Parallel to this one and this one. Got our OHs. Boom. 3 in a row. Don't need those axials. You can put H's on them if you want. Pick one of them to make a ester with phosphorus. So this O's really comes from the inositol, incoming inositol, and it's going to make a bond to that phosphate. And it's not going to look great, but just take that bond and make it there. And now it's not very equatorial, is it? Nice. So we have that. Move it down a little bit so it's not hidden by the question. Now we're going for the quick finish, finishing with stearic acid, which is 18 in a row. We've already got the carbonyl, need 17 more. Well, that's 44. I got my fixed lengths off. Sorry about the chem draw talk there. 17 more, 15, 17. And then the last one is lauric acid. Lauric acid has 12 in a row. If I didn't have this handout and I told you it was dodecanoic acid, I'd expect you to be able to do that too. I need 11 more. I got the 12th one already drawn. 9, 10, 11, 12. I need 11 more, not 12 more. Quick verification on the count before I let go. All the carbons appear to be accounted for. You would best be served if you did look up what use phosphatidyl inositols have in nature and the other 3 types found in chapter 26: phosphatidylserines, lecithins, and cephalins. I could ask about any of those during your exam. I hope you found this video on drawing triglycerides and phospholipids to be useful, and I look forward to our next video.